Hey everybody, and welcome to the Daily Space Weather. I'm your host, Dan, aka Smash-O-Mash, coming at you with some fresh new activity from the closest star. There have been coronal mass ejections, as well as a new increase in the sunspot number. We've got the highest number we've reached so far, as it exceeds 200. Radio flux over 220. And some coronal mass ejections. Are they earthly directed? We will let you know later in the video. So some more trans-equatorial plasma exchanges happening there in the past 24 hours. Again, several coronal mass ejections. And let's take a look at what's going on in terms of the filament fest, because it still continues. So have any of those filaments ejected that we've named? Well, so far, the Renee Gable filament is leaving sight here up around the North Polar region. The Ye filament, named for the artist formerly known as Kanye West, remains intact as well. And by the way, thanks for those of you who've been naming filaments. If you want to get involved, hit us up at Twitter at Smash-O-Mash. Down here, we've got the Bill Nye filament. Nope, that's still hanging out down there by the South Polar region. We've got the Zach Toven filament here. That has not ejected. We've got the Liver King filament here. That's not ejected. And then the Dan Nigro filament over here. I didn't name it. Zach Toven did, but there it is. Also not ejected. So, yeah. But there are coronal mass ejections. We'll get to their likely trajectory and timing later in the video. First, the northeastern limb as well. Massive sunspot group to the north of that flaring region there, to the northeast of it, this area up here. An insane number of sunspots up there, and a huge sunspot in the south. Check it out. There's the yesterday plus today SDO intensitygram from the SDO browse data section. Look at the size of this sunspot down here. That one is one of the largest of solar cycle 25 so far in terms of single umbral area. So that is quite a huge sunspot. It has gained magnetic complexity since yesterday. That is your SDO magnetogram from yesterday plus today. And let's briefly take a look at Croissant Earth. I'm interested in what volcanoes are erupting. Are you? Semeru is erupting. Not sure on the size of the ash cloud, but it's moving southeast. Popocatépetl exploding. Flight level 200 over central Mexico. That's a 20,000-foot plume of volcanic ash. Fuego volcanic ash not observed in Guatemala. Sangay in Ecuador exploding. Flight level 200, 20,000-foot ash plume over Ecuador from Sangay. Sabancaya in Peru exploding. Flight level 240. It's a 24,000-foot ash plume. And Villarrica, no indication on the size of the ash plume, if any, there, but it is producing some sulfur emissions. By the way, the Copernicus program, which is mentioned in this little blurb, can be viewed on the windy.com app, so check that out. We actually cover the windy.com website for some of our meteorology data. And thanks for leaving a comment, Smash-O staff. So here's the earthquake update here, the seismic activity in a convenient 90-day bar graph. Thanks to volcanodiscovery.com for that. And let's check USGS. So it's been pretty calm here for the past 24 hours. No major quakes. We've got a 5.0 at Vanuatu, however. A few quakes in the low 5 magnitude range, no major quakes. South of Japan, we had a 5.2 and also a 5.2 at Vanuatu. So things pretty calm seismically speaking here. There we go. There's the largest quake of the past 24. It's a 5.6 at Vanuatu. A great example of how all of those quakes were foreshocks, perhaps. And that 5.6 may be a foreshock to a larger quake. Remember, folks, any quake can be a foreshock. And let's get back to the basics of space. A frontier. There is the last 24 hours from SDO's viewpoint. Ionized helium, 304 angstroms. As the filament fest continues, the likelihood of additional coronal mass ejections remains nearly 100%. Let's take a look at some other wavelengths here. Again, back to basics. How about the house favorite while we're at it? 171 angstroms. And to show some additional features here, we will also add 193 angstroms to give a little bit of extra definition there. That composite is great at showing filaments. Also, any composite featuring 304 angstroms, also 211 angstroms, great at showing filaments. And let's take a look at some data here, since the 10.7 centimeter radial flux is now up to 228 solar flux units, well above the previous high. So the highest we saw up until this latest process of peaking, which we haven't even reached yet, was only 180. Now we're at 228 solar flux units. So a huge increase there as we forecasted yesterday. There you go. 228 solar flux units, sunspot number now over 200. Space Weather Enthusiast dashboard not forecasting any geomagnetic storms or geomagnetic unrest, except a tiny brief period of geomagnetic unrest forecasted for today. No refutation from me here. However, we do have a forecast coming for you later in the video. So, taking a look at the planetary K index here, that's a measurement of global geomagnetism, and we've got a KP 3.67 at the moment, having come out of a brief period of geomagnetic storm there. And we did indeed share some auroral imagery on Twitter. Once again, let's take a look at Earth's magnetic moment from space for the past 4 hours? We're hoping. There's Earth's magnetic moment from space. Whatever period of time that is, I'm not going to worry about it. Here's Earth's magnetic moment from the ground. I don't think that's 4 hours. We'll let it play through a second time since it looks like a shorter run. But you can expect to find some auroral imagery on the internet today. If you know about any yourself, or if you've taken your own, drop us a line. Maybe DM us on Twitter or even on Instagram. Next, looking at the real-time solar wind here, and we've seen this ongoing strong negative BZ. So this top line here, that red line right by my pointer, that's the vertical component of the magnetic field as measured at Lagrange 1. At the moment, it's being measured by the Discover, and that strong negative BZ signal could continue with geomagnetic unrest conditions. If we see an increase in the field strength or an increase in the density or speed, we could go back into geomagnetic unrest conditions. Current conditions are about 470 kilometers per second for the solar wind speed, solar wind density about 9.5 protons per cubic centimeter. And let's take a look at some magnetic data. There are your GOES magnetometers as we see this high-speed coronal hole wind stream continuing here. Let's take a look at the heliospheric current sheet. See a little bit of indecision happening there east of us and east of stereo A. You see this South Pole current sheet popping up. Not too surprising, as there is a lot of activity in the northern hemisphere. That latest sunspot to rise in the northeast is quite huge. It's really 2 sunspots, and there are a lot of umbrae there. So here's our line of sight field plot. You see some changes happening to the solar B field there, depicted in blue, as we watch Solar Cycle 25 advance in a spectacular fashion. Not looking like a weak solar cycle, is it? It's looking like Solar Cycle 19, perhaps. But in any case, there's our line of sight coronal hole plot. North Pole-oriented coronal holes rotating in here from the east. One of them across the equator. Right here, that is a North Pole-oriented coronal hole. That is SDO 211 angstroms wavelength. So this is North Pole. We can expect that to become geo-effective in about 4 days. Expect another high-speed coronal hole wind stream from that. Wait till I tell you what's going to happen in 3 days. Stay tuned. We'll get to it. Next, looking at flare probability. The likelihood of major flares nearly 100%. As 3182 sets, it becomes more and more likely to produce large flares. These sunspots here, especially 3192 and 3191, very, very likely to produce M or even X-class flares. Also, these interesting interactions between northern and southern hemisphere sunspots we've seen 2 days in a row could continue. Those could cause additional coronal mass ejections, solar flaring, etc. Look for unstable filaments to kick off these events. Here's the last 24 hours with SDO magnetogram. And let's switch to the intensity gram. Now, most of the sunspots on the Earth-facing portion of the solar disk here have been stable over the past 24 hours. No major changes happening there. Let's zoom in a little bit closer here. That's just not close enough. There we go. And that is a lot of sunspots. Some small, some huge. That one in the southeast features a light bridge. That's one of the biggest umbrae we've seen during the solar cycle. That's like 2 Earth diameters. And let's move on to energetic particles and solar flares. So have we seen any relativistic particles from the recent flaring activity? Well, no, not in the past 24 hours. Nothing bringing that proton flux off of the floor. Here is our GOES X-ray flux, and we had these 2 rather lengthy duration M-class flares. This one was a double peak. That one was the largest. It was an M6.03. And there were some coronal mass ejections associated with those solar flares. We'll get to it in a moment. First, the last 24 in SDO 131 angstroms. And as we forecast yesterday, one of those M-class flares came from the northeast, and one of those M-class flares came from the southwest. Here it is in 94 angstroms. Do you remember me saying yesterday that the most likely places to see a flare would be down here or up here? Yeah. That's called actual forecasting. How about if we combine the wavelengths? 94 plus 131 together. And let's take a closer look at some of those flaring events while we've got the composite ready to go. So here you go. Here's the eastern equatorial region. Once again, we see that trans-equatorial plasma exchange happening there. Plasma indecisively streaming back and forth between 2 sunspot groups there, one in the north, one in the south. Not something you see every day, but we showed a similar thing yesterday on the channel. Here's the southwestern region. No trans-equatorial plasma exchange happening there, however. That did generate a coronal mass ejection, which we will get to here after we step back for one moment and take a look at what's going on over the skies, over the heads of we Lehigh Valley residents. So here is our star chart. You've got the Mercury rising. You've got Mercury rising ahead of the sun. Also the moon high up there on its path. The yellow line is the ecliptic. The blue line is the galactic plane. And that star chart is from in-the-sky.org. If you've gotten up before dawn, you may see Mercury rising if you've got clear skies and a low horizon and not a lot of light pollution, because Mercury is kind of dim. Next, your solar system forecast as Mercury speeds away to the empty side of the solar system. Here's where things will be in 1 week. We will have a new moon on the 22nd. And let's take a look at coronagraphs. So, there have been CMEs, and at least one of them has an earthly directed component. It's the one happening late in the day yesterday on the 14th. Those are 92 frames. Let's also take a look at today, since some of that propagation spilled over into today. That's January 15th. And yes, there is likely an earthly directed component here. So let's switch to stereo A, which does have sufficient data. Stereo A located at Lagrange 5. And we'll also look at Soho-Lasco C3 at Lagrange 1 on the right. Now, we've paused this yesterday at 1638 for stereo A and 1630 for Soho-Lasco C3. So you can see this thing here. It's like shaped like a little curly, like a 9 or a 6 or something like that. See that? That's clearly the same CME. So let's start there. And as we advance this forward a little bit, we're going to see a second CME start to propagate right there. Now, from this perspective, Earth would be off on this line. And so from that perspective, it does appear to be earthly directed. Now let's see what it looks like from Soho-Lasco C3. So there we are at 238 Universal Time this morning. And let's see what it looks like from Soho. You can see most of that ejecta is likely to miss Earth to the south and the west. However, I believe one small component, a portion of that component is going to strike Earth. We can expect a minor CME impact here on the 18th. So midday on the 18th, expect to see that CME arrive here at Earth. And coming out of the backside here, 442, right? 442. There you can see a second CME event. That is on the opposite side of the sun. That is depicted here on Soho Lasco C3. So we do have one earthly directed CME and two non-Earth directed CMEs. And as we advance this further, that's what I'm seeing. Let us know what you think in the comments. If you think I'm wrong, or if you think I'm right, or if you are neutral and you just want to wait and see what happens on the 18th. Expect a CME impact on the 18th. Now, this could cause a co-rotating region, a co-interactive region there, because there is a coronal hole high-speed stream on the way also. Those things can interact as they travel through space. They can amplify or they can de-amplify each other depending on things like polarity and their rotation and their speed and the density of the coronal mass ejection and so on. So that can affect things. Let us know what you think will happen in the comments. We are expecting, I'm going to say, a KP5 event, a minor geomagnetic storm, midday on the 18th. So on Wednesday, January 18th, expect a coronal mass ejection impact. No, it's not going to destroy all of civilization. So here's the last 24 hours. And it's this one that's mostly off to the southwest. That has an earthly directed component. Keep in mind, Earth is moving in that direction. Here's the full zoom out. Which brings us to filaments, because once again, the likelihood of additional coronal mass ejections remains at nearly 100%. So here's Cerro Tololo's ground-based solar observatory hydrogen alpha imagery. You've got Renee Gable, you've got Ye, you've got Zach Tovin, you've got Bill Nye, you've got Liver King, that's this one up here, and then you've got the Dan Nigro. I guess we could name this filament over here, the one south of these crazy sunspot groups. That one's kind of likely to eject, considering how active that sunspot region has been. So let's go to Twitter and tweet live once again for your viewing pleasure. I know, it's exciting, right? Don't worry, Twitter. Twitter, you can handle it. Twitter, can I tweet? Would that be okay? No, that's okay. We'll wait. Pardon the technical difficulties that Twitter is experiencing. We, however, are not experiencing any technical difficulties. It's just Twitter, the barely functional junkware platform that continues to censor people. There we go. Oh my God, it's perfect. Name that filament. And we're talking about this one up here, as it's not going to destroy civilization or kill you, but it might create some mid-latitude aurorae if it does eject in an earthly direction. If you're not on Twitter, get on Twitter. I don't know what social media you like, but it's a little bit less pathetic than Facebook. Here's the last 24 hours in 94 plus 335 angstroms. That should give some additional definition to the last 24 hours of activity on El Sol. And here's the last couple of hours from GOES 16 SUVI. So lots of filaments, high likelihood of coronal mass ejections, nearly 100%, nearly 100% likelihood of additional major solar flares, as we see solar cycle 25 completely shattering a lot of terrible forecasts for a grand solar minimum. It looks nothing. It looks less and less like a grand solar minimum. I assume the cultists will continue doubling down and attempting to gaslight people and suggesting that they were right all along in their ridiculous, nonsensical forecasts based on imagination and one science paper examining the magnetic dynamo. Continuing on to our bonus features segment, we've got some satellite charging hazards here, surface charging variety over the central Pacific Ocean. Those are caused by low-energy electrons building up on the surfaces of satellites. You could see some signal reduction there, some less quality signal there over those locations that are showing up as red. Electron flux here still kind of low, and we can expect to see this rise precipitously here after this coronal hole high-speed stream ends. Let's see what NOAA thinks. There is a NOAA forecast only expecting a small increase there. So we'll have to see what happens there. That's your relativistic electrons forecast. There is your one-year graph to put it in context. Kind of a long time here of being at the low end of things. And let's take a look at the F layer of the ionosphere next and the vibrational frequency therein. It's the bridge between Earth and space. It's located at about 300 kilometers of altitude. There is one slice of Earth's upper atmosphere. That's the 300-kilometer range there. And we're seeing some major anomalies once again in the ionosphere. So it's been going on for weeks, probably like a month by now. See our earlier videos for additional information about it. You'll even see the ionosphere map sometimes appearing on our thumbnails. South Pacific anomaly here remaining in place around the 30 south latitude line. And since we're coming at you so late today, let's bring up the latest image. Actually, we'll show the anomaly gram first. There is anomaly in megahertz from a 30-day median. We're seeing continued rapid swings there. Wild low-frequency anomalies around the South Atlantic, southern portion of Africa, South America, and even portions of the South Pacific there. Ongoing low-frequency anomalies. Also high-frequency anomalies around the North Polar region and the equator. Here's the latest image. That's 1345 Universal Time ionogram. And there's 1345 Universal Time anomalygram. High-frequency anomalies here over the Middle East at the moment. Continuing on to our total electron content forecast, it shows you the free electrons between your GPS satellite and your handset. That GPS satellite is located in the inner portion of the outer Van Allen belt at about 12,500 miles of altitude. And here are the free electrons between it and your GPS handset. So huge GPS errors here continuing. This is actually the most globally widespread high electron content that we've ever shown on the channel. That is extremely anomalous. That is typical of only really high speed coronal hole high speed wind streams and so on. So some odd rifts happening there, some huge GPS errors. That is the most anomalous total electron content that we've ever shown on the channel, having done these videos for pushing 6 years now. I think we'll be at 6 years in May or June. I'll let that play through one more time. Also some odd anomalies here over the Caribbean there, seeing low electron contents over certain regions, southern South America. Very odd total electron content. Expect massive GPS errors all around the world. Next, the latest intensity gram and latest SDO magnetogram. So let's take a look at this sunspot group. It is quite complex indeed. Look at the number of ombre there. That thing is berserk. They're pretty big ombre, and they are certainly beta gamma delta class, those two sunspot groups. And of course, they are interacting with this massive sunspot down here. Look at the size of that thing. That is one gigantor. DAG. And it is now beta gamma class. Not really beta, gamma, delta class. It's pushing the boundaries, though, folks. So, yeah, since it's contributing with the activity to the sunspots to its north, it's certainly interesting to say the least. So, lots of magnetically complex sunspot groups, a CME on the way, and all sorts of other anomalies to cover. And that is the end of our space weather content. So we're going to continue on with some meteorology stuff. It's a little bit too easy to forecast the weather, but we don't mind sharing. So here is the little advertisement for smashomash.com/smash team. It's our subscription services site. If you want to support the channel, become a member of the Smash team at the gold or silver level. There's also a bronze level. We do send out email alerts, so sign up for those if you like. If you want to see alerts about things like tsunamis, typically before USGS comes out with them, then become a member of the Smash team at smashomash.com/smash team. We are still on Patreon as well. So if you want to support us that way, become a patron. If it's more convenient for you to help us out, increase the probability these videos will continue to exist, remain publicly visible and free for all to view by supporting the channel via your clicks, etc. Today's featured product is our bestseller, Do Not Pole Vault the Caldera, because if you're going through hell, keep going. That's our top seller. And thanks to all of our pals who've picked up merch. It comes in all sorts of different forms, whether it's a mini skirt or a tote bag. We've got a Smash Team duvet cover, actually, on our bed right now. And the print quality is very, very high. If you're going on a volcanic vacation, leave your vault pole at home. Don't pole vault the caldera. This public service message brought to you at massive personal risk and expense by Smash staff, and I so give Smash staff a raise by picking up some of our great merch. If you visit the link below the video to the Redbubble shop, you'll find the products in order of best selling. Here's a quick rundown of what it includes. And we've decided to make merch because reasons. Congratulations on surviving a global pandemic so far. You're doing a fine job. Press like and subscribe if you enjoy the content on YouTube. And thanks to our YouTube subscribers for tolerating the pathetic censorship on the platform. It is utterly putrid. And of course, for some reason, it seems to promote nonsense, fraud, and propaganda and suppress facts. But in any case, it's where most of our content is located, which is why we insist. Also, along with the fact that there are 1 billion plus daily users of YouTube, we insist that Alphabet fix the software, or Google, or whoever's in charge. You can also assist us with clicks by heading to smashomash.com. Links below the video to that as well. That is our homepage, and welcome to the Neo-Renaissance. Congratulations on realizing that the channel exists. We're not kidding. We're about to publish a paper explaining the mechanism behind the solar sunspot cycles, and let's move to meteorology. So we're taking a little bit of a look here at low pressure. So this is the lowest pressure in the world as far as I can tell. It's actually dropped since I did show prep. It's now at 948 hectopascals. That is like a hurricane in the Southern Ocean, basically. And I'm prefacing this because of this low off the coast of the eastern U.S. We've also got a low right there, kind of off the coast of New Jersey is the center of that, although it's nowhere as low as that one by Antarctica. That's 991 hectopascals. There's the North Polar region. We'll show you a quick view here of pressure. That is mean pressure at sea level. And let's see what's going on with the wind. So there's our wind map. That is the surface wind scenario for the eastern world. Shout out to our viewers from all around the planet. There are the jet streams of the east. We see a concentrated jet stream here diverging in the North Pacific once again, blasting weather into Northern California. Exactly what it doesn't need. There are the jet streams of the western world. Huge bends in the central Atlantic Ocean there, and a bit of a breakup of the jet stream over the U.S. Here are the surface winds. of the western world. You can see that low rotating there. A few hundred miles off the coast of New Jersey. Here are the surface winds of the central world. And don't forget the jet streams. Thanks to each one of you viewing the content. And if you've never left a comment before, let us know where you're located. These are clouds and fog over the Americas. Let me scroll back down here as I'm wasting part of the screen. Let me get rid of that white bar for you. There's a little more data. That is what Croissant Earth is looking like after the imagery has been stretched out to fit on a fake spherical map by NASA. If you still think the Earth is spherical, what kind of crazy lunatic are you? Everybody knows that views our channel that the Earth is croissant-shaped. And thanks for leaving a comment. A cookie spacey. Next, our weather.gov map. If your area is lit, click your area. It's very cold in Florida right now. Check it out. Hard freeze warnings. So stock up on orange juice, perhaps. I don't know. Whatever. Again, if your location is lit, click your location. We've got frost advisories and hard freeze warnings there on Florida. Let's take a look at a forecast. Here's your GFS pressure and precipitation forecast. As additional moisture continues to inundate California. Here is our total accumulated precipitation forecast. Now, these are all the same model, the GFS 72-hour forecast. We use it because it's accurate and not alarmist crap, like so many YouTube channels post on the regs. Since some of that precipitation will fall as snow, there is our total accumulated snow depth change, our positive snow depth change in inches. Lots more snow here coming to the southeastern portion of California. Also, Maine is going to get blanketed pretty hard. We'll also show the temperature anomaly forecast. That is surface temperature anomaly based on the same model, the 72-hour GFS forecast. And it's some cold days for Cuba and Florida there. Like 12 to 15 degrees Celsius below normal. And some hot weather coming to the Mississippi Valley and the Great Lakes region, and indeed the Mid-Atlantic states. Next, we'll take a look at a satellite map. And again, the Copernicus data is actually in here on windy.com. So if you want to look at that Copernicus data, it is in there. Certain layers are put in there by Copernicus. I'm not sure if it's, I think it's, let's see, I think sulfur dioxide. There you go. So sulfur dioxide is one of the ones that Copernicus monitors. And of course, there you can see Popocatépetl's sulfur dioxide output. It puts out quite a lot. So if you want to check that out, windy.com, they got a great mobile app. And let's move on to our lightning mapper. So we've got some significant lightning there in the western Atlantic over the past about 12 hours. Centered around that low pressure off of the coast of Jersey. And let's take a look at some real-time lightning maps. No terrestrial strikes in the U.S. The eastern Mediterranean looks like it has some active cells. Next time you hear thunder, check out lightningmaps.org. It could save your you-know-what, perhaps. It'll show you the teeth of the storms. And let's close this thing out with U.S. Doppler radar. Let's try again. U.S. Doppler radar. How about if we focus on the lower 48? Here is shortwave radiation showing clouds and fog. Great imagery there of that rotating low in the western Atlantic. It is slowly moving to the east. Lots of low clouds over the eastern seaboard and the Gulf of Mexico. You can see those low clouds showing up there, very obvious. And there is water vapor. That should clear things up if your Doppler radar is not giving you the full story. We've got all this moisture butting up against this effectively high pressure zone down here. So even though this air is likely warmer, it is also drier. So huge pressure gradients being created there. This whole string here, this is all high pressure relatively speaking. Dry air. It's more massive than moist air. Here's your recap, U.S. Doppler radar. Shortwave radiation showing clouds and fog over Crescent Earth. And there is water vapor. That's where we'll close things out. So thanks for tuning in to the Daily Space Weather, the main feature of the Smash News Network Least Busted Name and News. We just add that extra stuff just to get it all in one convenient place for your viewing pleasure. So thanks for tuning in. Congratulations on realizing the channel exists. I'll have been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back. Facts stated in this video suppressed by big tech criminal organizations to improve your online experience. Opinions stated in this video not necessarily the opinions of Smash News Network Least Busted Name in News.